Hello dear students, hope you're all doing well. In this video we're going to talk about periodic properties, or we can say electron configuration and periodic properties. Periodic properties, we're going to talk about atomic radii, ionization energy, electron affinity, ionic radii, valence electrons, and electron negativity. We're going to talk about these properties of the atoms and how they change across a period. We're going to define each of them and how they change in the periodic table. Means in the periodic table, as we move from left to right, how atomic radii changes, or as we go from top to the bottom, or as we go down the group, how are these properties changes. Okay, we start with atomic radii. Let's start. Atomic radii, you remember that in chapter 3 we talked about when we measure the size of an atom has a size, so we must know the radius, atomic radius, right? So this is ideally the atomic radius is defined as the distance from the nucleus to the outermost shell of an atom. Look, we have an atom, Basha, an atom, okay. We have an atom, okay. We know atom has a nucleus. The distance from nucleus to the outermost shell, for example, we can have two shells, but the distance from nucleus to the outermost shell means valence shell. So this is called atomic radius or atomic radii. Radii is plural. Okay, so this atomic radius, ideally, we measured like that. But when we measure, but we don't use it, ideal, because indicating the size of individual atoms, imagine this is one chlorine atom. So this is it's difficult to measure the size of an atom individually. So it's difficult and varies. We express their sizes when they are bonded together. Okay, when they're going to bond together, then we're going to measure the size of the atoms. Look at here, or we can say atomic radius or atomic radii is often described as 1/2 distance between the nuclei of identical atoms they're bonded together. Imagine, look at here. We have two chlorine atoms. Basha, chlorine, we know that chlorine element is diatomic molecule. So they're bonded together. When they're going to bond together, we measure the distance from the nuclei, distance between nuclei of these two atoms. Basha, this distance is about 200 picometer. It's very, very small, but the half distance is called atomic radius. So the atomic radius of one chlorine atom is 100 picometer. So atomic radius, we can say ideally is the distance from nucleus to the outermost shell. This is the size of atom, but it's difficult. It varies, and it's difficult to indicate. So we're going to use another method when they're bonded together. For example, diatomic molecules is going to be like that. For metals also, when they are, metals, they bond to each other by metallic bond. Later we'll talk about. Okay, so atomic radii is used to indicate the size of the atoms. Okay, now we know how the size of atoms are indicated. Now we're going to talk about how are the size of the atoms in the periodic table, how they change. Period trend. Period trend means as we go from left to right in the periodic table, how does atomic radii changes باشا بزنی چون گارت. It says as we go from left to right in the periodic table atomic radii decreases. What does mean decrease? Means the size of the atoms decreases. Look, let's take period 2. Look at the period 2. In the period 2, we have 8 elements. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. But if you look, this is period 2. This is lithium, Basha. And beryllium, boron, carbon, nitrogen, this is fluorine. What do you see? Look, as we go from left to right, the size decreases. Okay, we all know size decreases, but why? Because of what? Increasing positive charge. Why? When protons number increase, when we say positive charge, we mean protons number. We know that from left to right, atomic number increases, right? For example, atomic number of lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7. Look, atomic number increase means number of protons increase. Basha, when number of electrons, protons number increases across a period and shell number stays same, look, shell number stays same. Basha. Guys, across the period, always number of shells does not increase. What does mean number of shells? It means the number of shells they contain electrons does not increase. For example, for lithium, it has only 2 shells that contain electron. Fluorine also has what? Has 2 shells. Look at here, lithium and fluorine. Basha. Lithium and fluorine, both of them, they have only 2 shells. For lithium from left, fluorine from right. So across the period, number of shells stays same. Basha. When number of shells stays same and protons number increase, what increases? Attraction increase. What does mean attraction? Guys, this is the number of protons. Protons, they have positive charge. This is the electrons number, Basha. So, between protons and electrons, we have attraction. Basha, we have attraction. They attract each other. Look at here. Same charges, the different charges. They attract each other. Same charges. They repel each other. Basha. Between protons and electrons, we have attraction. So, as we go from left to right, attraction increases. Look, we know that outer electrons, they repel each other. Electron repels that electron. This electron also repel the outer electrons to the outward. And these electrons, we can say inner electrons, do not let the nucleus attract the outer electrons. Basha? At this time, so inner electrons, they shield, they prevent outer electrons being pulled by the what? By the nucleus. Inner electron they make shielding effect. يعني شي shielding effect. Shielding effect means shielding of outer electrons by inner electrons. Inner electron they repel outer electrons. يعني do not let there is a repulsion and there's attraction. So we know that attraction is more than the repulsion here. They have only 2 electrons repel 1 electron. But at the same time, they have 3 protons, they attract the outer electrons. Masha? The inner electrons, they make shielding. And they prevent outer electrons being pulled by the nucleus. And prosopeutrici shielding effect. Okay, know this. Basha. As we go from left to right, number of protons they are increased, right? So now, but what about inner electrons? Inner electrons, they're same. Basha. So when inner electrons means same, means there are only two defenders. اتواني electron inner electron كان defender. يعني they repel outer electrons. And they don't let protons attract them. But here for lithium we have two. For fluorine also we have two. But number of proton كان اتواني بيبلين striker كان هيرش كان أو أنا تشين they can attract the outer electrons strongly. And they can attract strongly. We can say attraction increases when the look, because from left to right, shell number does not increase, protons number increase, and shielding effect is going to stay same. Basha, and number of protons increase. At this time, attraction increase. Watachi, these electrons, they're going to be strongly pulled by the nucleus. When they are strongly pulled by the nucleus, the atoms get closer to the nucleus, then the size decreases. Basha? So, what you need to know here, you need to know that as we go from left to right, size of the atoms decreases, or we can say atomic radii decreases because of what? Increasing nuclear charges. Why? Because from left to right, size shell number does not increase. What does it mean? Shell number increase, size increase. But here, shell number stays same, protons number increases, so attraction increases. When attraction increases, so electrons get closer to the nucleus. Basha, know this. And you know why attraction increases, because we have shielding, but shielding effect does not increases across a period, means inner electrons do not increases, means there is not high repulsion, there is high attraction. Attraction is more than repulsion, so electrons get closer to the nucleus. Okay? Let's talk about down the group. As we go from from top to the bottom, Basha, as we go down the group, size of the atoms increases. Why? Because of increasing nuclear charge. Guys, as we go from left down the group, as any atomic number, for example, atomic number lithium is 3, sodium is 11, potassium is 19, rubidium is 37. Atomic number increase. Also across the period, atomic number increase, but it means electrons number increases, but shell number does not increase. But down the group, when electrons number increases, as we go, shell number increase. Look, this is lithium, and sodium. Basha, lithium and sodium. What do you see? Shell numbers, they have increased. When shell number increases, look, the distance from nucleus and the outermost shell increase. اما ليرة radius كمان increase به. لبروي shell number increase, electron get farther from the nucleus. So at that time, radius increase, size increases. Okay, just know this. Look at here, sample problem 5. Of the elements magnesium, chlorine, sodium, phosphorus, which has the largest atomic number. Assignment and the exam also, I'm going to give you some examples: magnesium, chlorine, sodium, and phosphorus. This is an example. Pemble, which one has the largest atomic radius? How do you know this in the exam? First of all, you must know that they are in the same period or same group. Basha, how we know? First, order them according to increasing atomic number. Atomic number كانت, I'm going to give you, chlorine is 17, Basha, sodium is 11, phosphorus is 15, Basha. So, what comes first? Sodium, Basha, sodium is 11, Bash duater magnesium comes. After magnesium, according to increasing atomic number, phosphorus comes. Basha, phosphorus is 15. Zor Basha. Then chlorine. Chlorine is 17. First of all, as I said, order them according to increasing atomic number. What comes first? Sodium, magnesium, phosphorus, chlorine. Basha. Now, you must know that they're in the same period or same group. How do I know? I give you atomic number. So from this, you can find the period and group. Sodium, this is atomic noble gas notation. You can write electron configuration notation. Neon is 10. Basha, then what comes? 3s1. با magnesium basha. عملت period ka. اما زنیم با period we look at the number before last is highest occupied energy level. Period here is 3. Group is what? Group is how we indicate the group, the number of electrons in last s. اما زنی عملت group ka. The group configuration is NS1. This is in group 1, right? We learned in chapter 5, section 2. Here for magnesium. Magnesium, again, neon, 3s2. Basha. Lera Amazani, it's in period 3, group. This is NS2, right? This is group 2. So, just do it for 2 of them. It will be clear that they are in the same period or same group. Ama, they are in the same period, but their group is different. For phosphorus or chlorine, they are also in the 3rd period. If you write electron config, also they are in different group. When we know they are in the same group, the same period, Esazani, they are in the same period. What should I know? I have ordered according to increasing atomic number. So as we go from left to right across the period, what increases? Atomic radius increase or decrease? Atomic radius decreases. Kawata, magnesium is more than sodium because it decreases. Magnesium is less than sodium. This is like that. Magnesium also is higher than the phosphorus. Phosphorus is more than the chlorine. Kawata, the smallest one is chlorine and the largest one is sodium. Okay? Let's look at the next example. This is calcium, beryllium, boron, strontium. Okay. Calcium's atomic number is what? Is 20. Beryllium is 4. Barium 56. And strontium 38. First of all, what you're going to do is order them according to increasing atomic number. So, what comes first? Beryllium. Beryllium comes first. Beryllium is 4. Duaterchiet. After beryllium, calcium 20. After calcium, then what comes next? Strontium. After strontium, then barium. Bash. Now this is beryllium. Strontium is 38. Barium is 56. Bash. We have ordered according to increasing atomic number. What you must know next, are they in the same group or same period? Beryllium, and this is 1s2 atomic electron configuration, 1s2 2s2, isn't it? What about for calcium? Calcium, let's try noble gas notation, much easier. No neon, we can use argon, isn't it? argon. Argon's atomic number is 18 after what comes for S2. Basha. Then you were there in second period. This one, beryllium, but calcium, it's in fourth period. But group, both of them, they have NS2 group configuration. Both of them, they're in group 2. Kata, from these two, we know that they're in different periods. I'm going to ask you a question in the exam. They are going to be in the same period or same group. So they are in different period, but they are in the same group. Which group? They are in group 2. Basha. All of them, they're in group 2. So down the group, imagine we go from top to the bottom. Basha. You're going to write vertically. It's much easier. Basha. So as we go down the group, what increases? Size increases, ionic radii increases. So which one has the largest atomic radius? Barium. Okay, smallest one, beryllium. So in the exam, you're going to solve it like that. Okay. So practice is same as these two examples. You can do it by yourself. Okay. Let's continue. Ionization energy. Guys, if you have a neutral atom, how you can remove one electron from a neutral atom? By adding energy. So it says an electron can be removed from an atom. Look, this is a neutral atom. It has 2 electrons, Basha. You add energy. At the end, you can remove 1 electron, Basha, but the atom is going to be ion. Okay, look at this equation. We have an atom, it's neutral. You add energy, M plus يعني with, Basha, with energy, by adding energy. Then at the end, after the arrow, this is what you're going to get. It was going to be formed. You're going to get an atom with positive charge and plus 1 electron. An electron is not going to have positive charge. Means an ion, a positive charged ion with 1 electron. Basha, if it's not written anything, any number, it's number 1. Number 1. Okay, it's 1. So this equation tells us if you add energy to a neutral atom, you can remove 1 electron from this atom. Okay, then what forms a positive ion? Guys, positive ion means what? Means an atom has a lost electron when it's positive. When it's negative, we're going to talk about it later, means it has gained it. Later we'll talk about it. What's ion? Ion is an atom or a group of atoms. In chapter 7 we're going to talk about it, or chapter 6 also we'll talk about polyatomic ions, yani 2 atoms together, they have a charge. Here we're going to talk about just monoatomic ions, and 1 atom has a charge. If an atom has positive or negative charge, we call what? Ion. Basha? What's ionization? The process, any process that results in the formation of an ion is referred to as ionization energy. Ionization is the process of forming ion. And this process that a positive ion or negative ion is going to be formed, we call what? Ionization. Okay? We have another term. This is our topic, ionization energy. Ionization energy, guys, the energy we're going to add to an atom to take 1 electron, this energy is called ionization energy. Basha, ionization energy. This is the symbol of ionization energy. Or it says first ionization energy, because we're going to remove 1 electron from a neutral atom. Kata, for the first electron, because we can remove more than 1 electron, but for the energy we need to remove the for the first electron, we called what? First ionization energy. Basha? Okay, this is ionization energy. How ionization energy changes across a period? Ionization energy of the main group elements. Guys, here in this section, we're going to just talk about main group elements because D block elements, group 3 to 12, it changes. And you don't see a regular intervals. We talked about periodic law. We said periodic law when elements are going to be ordered, arranged according to increasing atomic number, you're going to see a regular intervals, يعني a property regularly increase or decreases. But we talked about atomic radii, which mean across the period decreases regularly. Basha down the group decreases. Why this happens? Because of elements are arranged according to increasing atomic number. But here, for D block doesn't work. That's why we are not going to talk about D block. For main group elements again, you all know group 1, group 2, 13 to 18. Basha. So for ionization energy increase across each period. Ionization energy increase means the energy you need to remove one electron increases from an atom. Why? Because due to increasing nuclear charge. Again, nuclear charge, but how? When nuclear charge increases across the period, let's take a same example. Period 2, for lithium, we need 520 kilojoule per mole, but for fluorine, we need 1681. Look, we need more high energy to remove only one electron. So, why? Across the period, protons number increase. When protons number increases, as the nuclear charge increases across the period, electrons become more strongly attracted to the nucleus, requiring more energy to remove an electron. And outer electron, they are not strongly attracted, they are strongly tied by the what? They are strongly held by the nucleus. So if you want to remove one electron, you need high energy to take one because it's strongly attracted by the nucleus. Electrona, each one of these electrons, they are strongly attracted. So if you want to take it, you need to add more energy. You need high energy. Basha? That's why across the period ionization energy increase. The energy you need to remove one electron increase because of increasing nuclear charge. In nuclear charge increase, attraction increase. Electrons, they are strongly attracted by the nucleus. We need higher or more energy to remove one electron. Okay, look at here, guys. In general, non-metals have higher ionization energy than metals do. Guys, why we study ionization energy? From ionization energy, we understand that metals, they need less energy. To remove one electron, you need less energy. And non-metals from non-metals, where are non-metals? From right side of the periodic table, as from left to right, ionization energy increase. Means if you want to take one electron from that atom, you need higher energy. Bochi, there's high attraction. We know that non-metals, they like to gain electron instead of losing. From ionization energy, we understand why non-metals, they gain, they don't lose. They don't like to lose electron. You need high energy to take. But metals, you need less energy to remove one electron because their atomic structure is like that. There's less attraction. Lithium, there's less attraction between the outer electron and the nucleus. So you need less energy. We understand from ionization energy, metals, they like to lose electron. Non-metals, they don't like to lose it. Instead, they like to gain. Okay, from electron affinity, we understand better. Okay, let's talk about group trends. Down the group, guys, as we go from top to the bottom, ionization energy decreases. واتر the energy you need to remove one electron electron اگر بتوه if you want to take this electron as we go from يعني take away this electron remove one electron as we go down the group the energy we need is going to be decreased because of what? Look, as we move down the group you are adding more shells to the atom. Atoms shell number increase. Shell number increase. Why attraction? Why ionization energy decrease? Because the outermost electrons are farther away from the nucleus. Electron is the valence electron of sodium compared to lithium. It's farther from the nucleus. Why? So when it's farther, as a result, they are less tightly held by the positive charge of the nucleus. Electron is what? Is less tightly held by the nucleus. There's not strongly pulled by the nucleus. You add less energy, then you take away this electron. That's why ionization energy decrease down the group. As we move down the group, number of shells increase. Electrons get farther from the nucleus. Attraction between the valence electrons and the nucleus decreases. As the result, we need less energy to take away a valence electron from the atoms. Okay, as we go down the group. Okay, that's it. Bash. We have removed one electron. Can we remove the second electron from an atom? Yes, but if you add energy again. Look, removing electron from positive ions. يعني an atom has lost one electron. That's why you say positive ion. Can we remove the second one, third one? Yes. With sufficient energy, electrons can be removed from positive ions as well as from neutral atoms. The energies required for second electrons from an atom are referred to as the second ionization energy. Pasha, look, atomic here has lost one electron. Look at here, imagine this is lithium. We have added energy, which is called first ionization energy. We have added 520 kilojoule per mole. Now we have removed one electron. Electron remove کرده. باشه? Then, if we add this energy again, we can remove the second electron from this atom. So, if we have a positive ion, we add energy again, plus with energy, at the end, what happens? We are going to get a positive ion again, but with 2 positive charge. Okay, lithium 2 positive charge means it has lost 2 electrons. Look, plus 1 electron. يعني step يدوم. Next second step, 1 electron has removed. But from the first step, here 1 electron also here. But here is about the second step. I'm جاري باشا second step. Okay. Kawata, the energy we need to remove the second electron from an atom or from a positive ion atom is called energy PLNG, second ionization energy. Basha, this is second ionization energy. Okay? Basha, the energy we need to remove the second electron is more than the energy we need to remove the first electron? Yes. The energy energy, look at here. Agar lithium atomic manhabe, if we want to add 1 electron, remove 1 electron, sorry, we need 520 kilojoule. But for removing the second electron, we need high energy, 7,298. Why? Because the attraction of electrons to the nucleus increases with the removal of electrons. There will be less electrons and more protons. Look at here. Let me erase it first. Why second ionization is more than the first? Later, when electron is going to be removed, and you have removed one electron here. Now we have, before, when it's neutral, we have 3 electrons, 3 protons. When you have removed one electron, now we have 2 electrons, 3 protons, and shell number has decreased. Why? So now we have high attraction. Protons are more than electrons. At this time, the attraction increases. They are going to be strongly attracted by the nucleus. So at this time, you need high energy to remove the second electron. What about the third? اگر بمعنی remove the third electron. electron remove, okay? We need about what? Look at here. 11,815. Look, for first ionization energy, hydrogen has only 1 electron, so it has only 1 ionization, first ionization energy. Second, third, lithium has 3 electrons, it has 3 ionization energies. Kata, look, second ionization energy is more than the first, look, and third is more than the second, fourth is more than the third. Why? Because with the removal of electrons, there will be less electrons and more protons, and at that time attraction increases. When attraction increases, we're going to need more energy to remove an electron. Observe, when attraction decrease, ionization energy, when attraction decrease, ionization energy decrease. When attraction increase, ionization energy increase. When does the attraction increase? Across the period, down the group decreases. Okay, let's continue. We have an example, guys. Here we have 2 elements, element A and element B. Basha, they are hypothetical elements. Element A, element B. A has the first ionization energy about 419 kilojoule per mole. B has first ionization energy 1000 kilojoule per mole. Decide if each element is more likely to be in the S block or P block. Which element is more likely to form a positive ion? Basha. We have element A, element B. Element A and element B, their first ionization energy is what? A is 419 kilojoule. B is about 1000 kilojoule per mole. Basha. Which one is more likely to be in the S and P block? S block is group 1, group 2. P, it's group 13 to 18. And in P block, they are from right. S, they are from left. Basha. We know from left to right, as we go from S to P block, from left to right across the period, what happens? Ionization energy increases. Kata, which one is more likely to be in P? B. Why? B ionization energy is more than the A. So it's more likely to be in P, because P block, they are more than the S block, their ionization energy. Basha? So here, this is B, and this one is more likely to be in S block. We don't know which element is that, but we know it's more likely to be in A. It says which element is more likely to form a positive ion. Which one is more likely to form a positive ion? A, because A's ionization energy is less than the B, so it's more likely to form a positive ion. The one that has less ionization energy is going to be more likely to form a positive ion. Basha? Let's continue. Practice. We have some hypothetical elements. QRTX have the outer electron configuration indicated below. Then answer the following questions. أما element كان باشا. على Identify the block location of each hypothetical main group element. Which of these elements are the same period? Question B. And which are in the same group? Which elements would you expect to have the highest first ionization energy? Let's answer the first A and B. Azanin, Q it's in P block, R it's in S, T it's in P, X in the P. Kata Q, T, X there in this block P, just R it's in S block. Then period. For period, we look at the number before last S. I told you, or the highest occupied energy level. Q it's in third period, R it's in third, T it's in fifth period, and X it's in the fifth period too. Kata 2X, they're in the same period. Q and R also they're in the same period, but their period is different than T and X. Q and R they're in the third period, T and X they're in the fifth period. Basha. Group, this is for P block. We know number of electrons in last S, last P plus 10 tells us the group. Kata 2 plus 5 plus 10 equals 17. Q it's in Q at 20 billion later. Group 17, but which period? Period 3. Ama Q is right here. Pasha. What about R? R it's in group 1 and S1, and third period Kata R it's here. Pasha. Utman R Q they are in the same period. Okay. T it's in number of electrons in last S last P equals plus 10 equals group number. Group number is 17. Which period? 5. 1 2 1 2 3 4 5. Group 17. This is T and X there it's in group what? Group 13. But which period? Period 5. This is X. Now, which element would you expect to have the highest first ionization energy? Emma Azani, those that are from left, their ionization energy is less than the one. Those that are in right, those that are in the P block. S block, their ionization energy is less than the P. Basha. So across the period, ionization energy increases. So which one is going to have the highest first ionization energy? We know those they are from right. Kata QT, they have the highest ionization energy. But which one? If we want to indicate an element, an atom, Q or T, emazanin, down the group, ionization energy decreases. Kata T's ionization energy is less than the Q. Kata align Q has the first highest first ionization energy. Which one would you have? Which would have the lowest first ionization energy? Which have the highest first ionization energy? Pasha. Highest ionization energy, but the lowest is going to be R. R from left. Okay, that's it. Which element would you expect to have the highest second ionization energy? Guys, this question you need to think about it. Second ionization energy, each of these, R, Q, T, to removing the second electron. For first, we know Q is first, the highest, R is lowest. But for the second, the answer is R. R has the second highest ionization energy, but it has the lowest first ionization energy. Why? Because look at here, R, which is sodium, when it loses one electron, shell number decreases. But for these elements which are in P block, when you remove one electron, shell number does not decreases. Masha? And when sodium, when R, which is R, Pasha, when it loses, shell number decreases. Then when shell number decreases, attraction is going to be higher and higher. So then when sodium loses 1 electrons, it's going to have a stability like noble gases. How? Noble gas, they have 8 electrons in the last shell. Also, sodium is going to have 8 electrons in the last shell. So at that time, if you want to remove the second electron, second ionization energy, you need to add more and more energy. And the energy you need to remove to remove 1 electron from the R atom, sodium atom, is higher than the Q, T, and X. Okay? Because of this. And so which of the elements is most likely to form 1 positive ion? Again, R, again sodium. Because sodium, its atomic structure, it has only 1 valence electron. It's in S block, and so it has lowest ionization energy. That's why it's more likely to form 1 positive ion. Okay. Electron affinity. Electron affinity, we can say, is opposite of ionization energy. Is amount of energy is going to be released or gained when an atom electron is added to a neutral atom to form an anion. باشا. اما ionization energy outman chi. If we add energy to an atom, we can remove 1 electron. Now we're going to add electron. Guys, when you add an electron to an atom, the atom is going to lose energy. Instead, to you get something, you must lose something. That's like that. So you're going to buy something in a shop. So you must give money, then you can get, right? You must spend money, then you can get something. Also, atoms, to get 1 electron, they must lose energy. So they are not going to give money, and instead they're going to lose energy. Okay, so I'm a neutral atomic man here. Neutral atom means does not have charge, positive, negative. You add an electron to this atom. Masha, an atom with an electron. At the end, what do you get? An anion. We're going to talk about anion. Anion means a negatively charged ion. So then energy will be released. Guys, the energy is going to be released. We're going to write after the arrow because this is the product. Also, the energy of the release of energy is represented by a negative value. Energia, and it is going to be represented by negative. Means it represents that energy has lost. But guys, we have some atoms like noble gases, like group 2. In the class we explain it, that these the atoms of these elements, they don't have any attraction. They don't like to gain electrons. At that time, when they don't like it, what we can do? We force them. Forcing means you're going to add energy. Okay? Look, we have an atom. You add an electron, but you must add energy. Then the atom is going to gain an electron, is going to be a negatively charged ion or anion. Energia laberwi add bankerdua, we're going to represent by positive, and we're going to write before the arrow. But if it's after the arrow, means the energy has lost. Before means the energy has gained. Okay? If I ask you this question in the exam, you know that this equation represents an atom has gained an electron by adding energy. Okay? That's it. How electron affinity changes across the period? Electron affinity increase across the period. Why? Because of increasing nuclear charge. We know all the electron affinity, ionization energy, electron affinity, ionization energy, atomic gradient, all they changes across the period because of nuclear charge. But here, why nuclear charge increases? Why when nuclear charge increases electroaffinity increase? Because when nuclear charge increase, there will be attraction, strong attraction on electrons in the last shell. So there more energy will be released. إما electron is strongly attracted by the nucleus compared to this electron in the lithium, because across the period size protons number increase, attraction increase. Electron again, if I add a new electron Basha, let's use electron add kit for a new electron. Also, we know that there is high attraction. This atom has high attraction for this electron. Means it likes a new electron. When something has high attraction, category atomic has high attraction for an electron, means it likes to gain. So when it has high attraction, attraction boy here, because we know protons, they have increased, there is high attraction. You add one electron, electron is strongly going to be attracted by the nucleus. When an atom has high attraction for an electron, is going to release high energy. It's going to release high energy. But lithium, if you add one electron, so we know that there are 4 electrons, 3 protons, and also again repulsion is going to be higher, right? And then also this electron is not strongly, electron is not strongly. Also, if you add one electron to the lithium, also is not going to be strongly attracted by the nucleus. At that time, the lithium is going to release smaller amount of energy. Lithium is going to release minus 61. But here is going to release what? About, for fluorine, minus 339. Okay? This one, we understand that across the period, shell number does not increase, size decreases, ionization energy increase, also electron affinity increase, because when attraction increase, here let's talk about nuclear shell, there will be strong attraction of electrons on the last shell. When you add one electron, there's high attraction. An electron is going high attraction. Had atomic, when it has high attraction for an electron, means for a new electron, means it's going to release high amount of energy. Okay, guys, from electron affinity we understand that non-metals like to gain electron because of their atomic structure, because they have high attraction. Imagine fluorine, they are from right side of the periodic table, elements from right side of the periodic, they have a high attraction for electrons, means they like to gain electron. But metals like S block, metals, they don't like attraction, they don't like electrons. Why? Because they don't have attraction. Example, lithium, they don't have high attraction, so they're going to release small amount of energy. Okay, electron affinity decreases down the group. Why? Because when shell number increases, electrons, they are not going to be strongly attracted, they're going to be farther from the nucleus, results in electrons not have a strong attraction to the nucleus. Electron is not strongly attracted by the nucleus. To electronic you're going to add any electron. Also, this electron is not strongly attracted by the nucleus. Means when it does not have high attraction for that electron, it's going to gain it, but it loses a small amount of energy. Sodium 10 is going to release minus 54, lithium minus 61. Electron, compared to sodium, there's high attraction between protons, 3 protons of nucleus of the lithium and its outer electrons, compared to sodium, not fluorine. That's why when down the group, shell number increases, electrons going to get farther from the nucleus, and they're going to what? They're there's going to be less attraction between the outer electrons and the nucleus. When you add one electron, also the nucleus does not have high attraction for it. When it does not have high attraction, it means it's going to release less amount of energy. Okay, guys, look at the group 2, group 18, also nitrogen. It takes time to explain it, but I want you to know, maybe you want to know why there is zero. Zero means they don't have any attraction. They don't release any amount of energy for adding one electron. So they don't like it. When they don't like it, for these atoms, we're going to what? We're going to add energy. We talked about, this is about this. And atom like group 18, like group 2, nitrogen, we have also some other elements. They don't have any attraction for a new electron, so we must force them. We add energy to them. Then they're going to gain a new electron. Look at here, guys. Adding electrons to a negative ions. An atom has gained electron. Oxygen. But you add electron for oxygen. So تواني بمشي بيكين neutral oxygen كمان هي plus electron, يعني you add electron for this oxygen atom, then that's it. Then at the end, what you get a negatively charged ion of oxygen, but at this time energy what? Energy is going to be released. It's more difficult to add a second electron to an already negatively charged ion. اگر من اما الکترونیکم add کردوم, it has gained. اگر بمهوت, if I want to add, look, take this one, add the second electron. At this time, it's very difficult, not for oxygen, for all the other elements. So at that time, you must add energy. Masha? At this time, the oxygen is going to gain it. Gain one electron is going to be 2 negative. Means it has gained 2 electron. So, but at this time, energy must be added. Look at here. You add 1 electron to an oxygen, is going to gain it, but electron affinity is going to be negative. But for the second electron, you must add energy. Energy, look, is what? Is positive. Okay? That's it. So, for all the other atoms, when you add, if for the first electron is negative, for second is always positive. But for noble gases and group 2, their first ionization energy is positive, and also their second ionization energy is also their second electron affinity also is positive. But for other atoms, their first electron affinity is negative, but their second is positive for all elements. Okay, also you can read this. It's not very important, but it can help you to understand that paragraph. Neutral atom. Neutral atoms means number of protons, electrons are same and does not have a charge. Okay, neutral atoms, when an atom loses or gain, whenever an atom loses or gain electron, is going to be ion. But when it loses electron, is going to be positively charged ion. Positively charged ion PLNG, cation. A positive ion is known as cation. يعني cation is an atom had a lost electron. But when a neutral atom gains electron, is going to be negative ion, is going to be negative. Negative ion is known as anion. Okay? Look at here, cation formation. How cation forms? أما sodium معناها metals, they like to gain electron. We learn from electron affinity and ionization energy. So they like to lose it, okay? They like to lose electron. So when cation, when an atom loses, the sodium is going to be positive. Here, أما چند proton معناها? It has 11 proton. باشا چند electron معناها? 11 electron. كاتتو أبيب زانيت. It does not have a charge. So it's neutral. Protons, electrons are same. But here, when it loses one electron, now this atom is going to be cation, is going to be positively charged ion. Proton number, guys, always stays same in the formation of ion, when in the formation of compounds also. But here we have one electron has lost, so we have 10 electrons. Now, protons number are 11, electrons number 10. Kata, we have one more proton. At that time, when we have one more proton compared to the electrons, we give one positive charge. يعني one positive charge, we have one more proton compared to the number of electrons. Pasha? Anion formation or formation of a negative ion, atomic here like chlorine. Chlorine is a halogen, group 17s, they like to gain electron. So you're going to add one electron. When it gains this electron, what happens? Chlorine, when it's neutral, it has 17 protons and 17 electrons. Basha? Chlorine, we have 17, sorry. Yeah, I should erase it. When it gains one electron, electron number is going to be 18. Why? And this is going to be stay same. 17 proton. Now we have a number of electrons, they have increased. We have 18 electrons, 17 proton. So we're going to give one chlorine, one negative charged ion. Means we have one more electron compared to the number of protons. Why? 18, 70. We have one extra electron. We give one negative. When we have, for example, 18 electron and 17 protons, we give two negative charged ion. Means we have two extra number of electrons. Okay, Pasha. Ionic radii. We talked about atomic radii. Atomic radii means the radius of a neutral atom. What about the radius of ions? So does the radius of ions different or change when they lose or gain electron? When an atom lose or gain electron, the size changes? Yes, changes. But how? First of all, ionic radii is the distance between the nucleus of an ion and the outermost shell of the ion. أما استقليرة أما neutral atom nucleus to the outermost shell أما بيوتري atomic radius. But here, from nucleus to the outermost shell of an ion, this is called ionic radii. Basha أما ionic radii. Okay? That's it. So let's talk about how it changes. Ionic radii of cations. When an atom loses electron, so like sodium here, it causes decrease in the atomic radius. When an atom loses an electron, its size gets smaller because of removing highest energy level shell electrons gain to be closer to the nucleus by stronger attraction. Guys, when atoms they lose, like metals, they lose their number of shell decreases. Like sodium, so number of shell decrease means atomic radius decreases. Also, we can say electrons going to be less than protons they are going to be more than electrons. So at that time, when protons are more than electrons, there's high attraction means electrons get closer to the nucleus. At that time, ionic radii decreases. Formation of cations causes what? Causes decreasing in atomic radius because of what we talked about. Ionic radii of anions. When an atom gains electron, when an atom gains, like chlorine, what happens to its size? Its size gets bigger because the total positive charge of nucleus remains same. So the electrons are not pulled to the nucleus as strongly as they were before the addition of extra electrons. examine 11 protonum here, 17 for chlorine. There are 17 protons, 17 electrons. When it gains 1 electron, we have 18 electrons. Why? And 17 protons. Electrons are more than. When electrons are more than protons, it causes that repulsion increases compared to the attraction. There's an attraction, but it causes repulsion. And when there are more electrons and less number of protons, so at that time, electrons going to be pulled by the nucleus, but not strongly as they were before the addition of the extra electrons. Okay? When there are more electrons, attraction, we can say, decreases, and size. When attraction decreases, electrons are not going to be pulled by the nucleus strongly, then at that time size increases. Okay? Kata. When cation forms, when an atom loses electron, size decreases. When an atom gains electron, its size increases. Okay? Across period, guys, a period, ionic radii, anionic radii, the anionic radii, anionic radii and cationic radii decreases across the period. Seri Arabka. Because of increasing nuclear charge, and it's same as the atomic radius. Atomic radius decrease across period because of increasing nuclear charge, attraction increase, electron going to be get closer to the nucleus. What about ionic radii? Also, it's same. Down the group increases, and because of increasing number of shells. Okay, guys, look at this example. Esta amabo atomic radii before atoms lose or gain electron. Sodium, before it loses electron, its atomic radii is 152. Beryllium 112. Babbling. Esta, after losing electron, lithium is 76. Beryllium is 45. From 152 for lithium, it becomes 76. Beryllium from 112, it becomes what? 45. But still, beryllium is less than lithium after losing electrons too. Got it? 20 bling. Atomic radii, ionic radii, or cationic radii decreases across period. What about for anionic radii? Anionic radii means size of the negative ions. Where are the size of negative ions? Negative ions are liquid from right, because nonmetals, they are nonmetals, they like to gain electron, they become anion. So here, look at carbon, nitrogen, oxygen, fluorine. Look, carbon's ionic radii is higher than the nitrogen, oxygen that kata tumbling. For anions, from left to right also decreases. Okay, because of increasing nuclear charge. 20 compare K when they are neutral. Carbon when it's neutral, size K 77 picometer. After it gains, it increases. It becomes 260 picometer. But when both also increases, but nitrogen also increases. At the end, from left to right, atomic radius decreases, ionic radius decrease because of increasing nuclear charge. Down the group also, atomic radius, ionic radius increases also because of increasing number of shells. Okay, that's it. Valence electrons, guys. Valence electrons are important. There are two definitions for valence electrons. Electrons are available to be lost, gained, or shared in the formation of chemical compounds are referred to as valence electrons. Guys, those electrons, they are going to be lost or gained, shared. Basi ionic compound, molecular covalent compound, you have learned. Also, we're going to learn. Kati compound يدرس a bit. Electrons going to be lost or gained. Which electrons are going to be lost or gained or shared? Valence electrons. What are valence electrons? Or we can say another definition: valence electrons in the last shell are called valence electrons. Look at here for phosphorus electron ana kala last shell and pianalin chi, we call them valence electrons. Pasha Kata. For main group elements, the valence electrons are the electrons in the outermost shell or last S and P sublevel. Electrons in last S, last P, they are valence electrons. For group 1, group 2, electrons in last S. For group 13, أما main group canon, electrons in last S, last P. Okay. For group 1, group 2, elements have 1 or 2 valence electrons respectively. Guys, for group 1, group 2, number valence electron أكاتا group number. يعني شي. When group 1 means 1 valence electron, group 2, 2 valence electron. Basha? Okay. And their group configuration as any NS1. Group 2 is NS2, means they have 2 electrons in the last S. Basha? And they have 2 valence electrons. These 2 valence electrons, they are in the last S, in the last shell. But group 13, أما pianoline P block, why? أما S block. For P block, electrons in last S, last P are valence electrons. Group 13 group configuration, okay, NS2 P or NP1, to NP1. MS do electron P contains only 1 electron. Together 2 plus 1, 3. Okay, 3 valence electron. Or we can say group number minus 10 akatachi number of valence electrons. Asha, 13 minus 10 akatachi equals 3 valence electrons. I got a problem by telling the exam. How many valence electrons do the elements of group 17s have? How many valence electrons do they have? You say, teacher, you're going to think like this. Group 17, Basha, 17 minus 10, 7. So they have how many valence electrons? They have 7 valence electrons. Group 18 minus 10, 8. Group 18, they have 8 valence electrons, except helium. It has to. Main group 1, these elements, they have only 1 valence electron. They have only 1 electron in the last shell. I got to element, let's chapter 4, we learned that if I give you an electron configuration, how you can indicate the valence electrons. The electrons in the outermost shell, we have 3 shells. and the 3 shell we have 3s 3p electrons in last s last p here equals the number of valence electron. Basha. Electron negativity. Guys, electron negativity is important. We have to, when two atoms they bond, one atom is going to attract electron from another atom, right? And that atom is going to lose it. How this happens? Electron negativity is all about electron negativity. Electron negativity is a measure of the ability of an atom to attract electron from another atom. We have two atoms. I'm a chlorine. Chlorine is going to attract this electron and from the sodium, right? When it becomes NaCl, right? When it becomes NaCl, salt, chlorine is going to gain an electron. Why? And sodium is going to lose it. You might learn that chlorine has 7 valence electrons. It needs 1 electron to its last shall be filled to become octet, right? Sodium has only 1 valence electron. It's going to lose it to become octet electrons. We learn like that. But here we're going to explain in different way. Is about electron negativity. Is about ability of an atom to attract electron from another atom. Ability atomic attraction. When an atom has high attraction to electrons from another atom, it has high electron negativity. And chlorine has high attraction, high ability to attract electron, to take electron from sodium because it has high electron negativity. Okay? Let's talk about it. Electron negativity increase across each period due to the increasing nuclear charge. Ionization energy increase across the period. Because of increasing nuclear charge, when nuclear charge increase, the attraction for electrons also increase. As the result, electron negativity increases. Electron negativity, attraction ability of the nucleus of an atom to attract electron from another atom. Basha, esalera, chlorines electron negativity is 3. Sodium electron negativity 0.9. Kawata. Which one has ability to attract electrons, to take electron from another atom? Chlorine. Chlorine, very high electron negativity here. Bochi, it has high electron negativity because across the period, attraction increases. When there is high attraction, at nucleus chlorine, it has high attraction to what? To take electron from another atom. But sodium does not have that attraction like chlorine, because across the period, chlorine has more protons compared to sodium, right? So it has high attraction. High attraction means high ability to attract electron from another atom. Kawata. Which is why chlorine gains electrons from sodium, because it has high electron negativity. It has high ability to attract electron. Why it has high ability? Because it has high attraction. Okay, its nucleus has high attraction to gain electron, to attract electron from another atom. It's all about that. And we understand from this, metals, they like to lose electron. Why? Because they have the least electron negative activity. Alkali and alkaline earth metal, group 1, group 2, amana, they what? They are the least electron negative elements because they don't have high attraction for electron from another atom. Their atoms have low attraction for electron. That's it. It means they have low ability to attract. They have less attraction. We can say metals, they like to lose electrons, right? Because they don't have attraction, they're going to lose it for another atom, for another non-metal, right? Because they don't have attraction to attract electron from a non-metal, So when they don't have attraction, nonmetals, they're going to take it. Okay? Their electron, their valence electron. أتواني nonmetal especially nitrogen, oxygen, halogens, they are highly electronegative element. Fluorine electronegativity okay, 4, oxygen 3.5, all the halogens, they're known as high electronegative elements. Sulfur, especially nonmetals, we're not talking about noble gases. Noble gases, they're stable, they don't like to gain. We're not talking about noble gases here. But it's important you to know fluorine is the most electronegative element. Among the metals, among the nonmetals, among the elements in the periodic table, the most electronegative element is fluorine. It has high ability to attract electron from another atom because it has high attraction. And now across the period increase down the group, electronegativity decreases because attraction decreases. Shell number increases. When shell number increases, it causes decreasing it's going to decrease the attraction, right? Protons, shell number increase, attraction shell number increases, attraction decreases, electronegativity decreases. So at that time, when electronegativity decreases, so the electrons, they are going to lose electrons. Basha? This is about metals. Okay. Here we have some examples, and we solved this question like that. Outman, we're going to give you atomic numbers. Basha. Here it says all the, where is it? Gallium, bromine, calcium, Basha, these elements. They are in different group, isn't it? Bromine is in group 17, calcium it's in group 2, right? Okay, this is 31, it's in group 13, right? I think this is 31, 37, and calcium, fluorine, chlorine, and bromine. Okay, calcium is 20, isn't it? Okay, so they are in the same period, but they are not in the same group. When they are in the same period, or let's do it together. Calcium, calcium, we're going to order it according to increasing atomic number. Gallium 31 and bromine 37. Basha. So how we know that in the same group or same period? Outman electron configuration. Can you see for calcium, argon 4s2. Gallium is what? Again, argon 4s2. She had after that 3d10. After 3d10, 4p1. Argon, it's in group 2, and here number of electrons in last s, last p plus 10 equals group 13. It's group 13, and argon, it's in group 2. Got that? But what period? This is calcium, it's in period 4. What about gallium? Gallium, it's also in 4th period. Kata, just do it for 2 of them. You understand they are in the same period, not same group. Kata, across the period, It's all about which one has the highest electron negativity. Across the period, electron negativity increases. When it increases, we say the highest one is bromine. Okay, that's it. We have, I think we solved the question like that. Agar بين أما hypothetical elementin E, G, J, M, L. I'm going to do it in the this empty periodic table. Let's put in the periodic table. This element is in period 2, and which group 17. Okay, that's here. Okay, this is E and G, it's in group 17, fifth period. 4, 5, so this is G, Asha, and J, it's in second period, and which group? 2 plus 2, 4, 14, 14, and period 2, this is J, and L, it's in sixth period 17, this is L, Basha M, it's in second period, group 16, second period, group 16. Basha Cheaterman Mao. Yeah, they are only in P block, but E, G, L, they are in 17th group, M is group 16, second period, J, it's in group 14, second period. Yeah, that's it. Ale, identify the block, okay? It's not very important here. Which element would you expect to have the highest electron affinity? Electron affinity across period increase, down the group decreases. Why? Kata. As we go from right, electron affinity increase. Okay, E, J, L, we say they have high electron affinity, but which one, E, G, or L, has the highest electron affinity? E. Why? Because as we move down the group, electron affinity decreases. Kata E has the highest electron affinity. Basha. Which one would you expect to form one negative ion? Those they have high ionization energy. Which? Halogen, group 17. Okay. Which would you have the highest electron affinity? Electron affinity كم across period increase, down the group decreases. Kata E is the highest. Again, compare the ionic radii of typical ion formed by the element of G with the radius of the atom formed with which the ion was formed. Pasha, G. Where's G? Here. G is going to what? Is going to, it's a non-metal, it's going to gain electron. When G is going to gain an electron, a beta G, a negative ion, right? كتبت negative ion, it has gained one electron. We learned that when it gains one electron, an atom, its size increases, right? So we can say, so G when it's anion, when it's anion, its size is ionic radii of G is higher than its atomic radius. Why? When it's neutral, its size is smaller than when it becomes anion, right? That's it. Which elements contain 7 valence electron? Which elements? Elements of group 17. They have 7 valence electrons. E, G, L. All of these, they are in group 17. 17, group number -7 equals the valence electrons. Pasha? Okay. That's it. The periodic laws. You can use that diagram. you can understand better. It's going to be useful. Look, ionic radii, atomic radii decrease across period, down the group increase, but electron affinity, ionization energy, and electron negativity across period increase, down the group decreases. Okay, this is the section review. That's it. Thank you. Thanks for listening. See you next time.